Hi, this is Linda Noss, and this is the fourth video in the sorting series and the second one in the selection sort. So when we last left, ours looked like this. The -2 was in place. The -2 have flipped out with the 4 in the first position, and the 4 had been put where the -2 was. So now we have to come up with a generic way of making this happen for all the positions so that this thing sorts. If I had a small array, I could repeat these two chunks of code over and over again, just changing the 0 here to a 1 and then a 2 and then a 3. But that is not the most efficient way of doing it. So what I'm going to do is I'm going to put another loop in. So it goes through the loop. And since I'm putting another loop in, I need another looping variable. So I'm going to put j in there. So I'm going to start 0. And transverse through the whole array. And I want step 1 inside the loop, and I want step 2 inside the loop. And then what I want to do is I want to start switching these zeros out to something else. Now you'll notice that when j is equal to 0, I'm interested in the first element of the array. And when j is equal to 1, I'm going to be interested in the second element of the array, which is numbered with a 1, and so forth and so on. So instead of having a 0 here, I'm going to put j there. I'm going to put a j here. I'm going to put a j in where pretty much all the zeros are. When I save that, then I can run it and see what happens. And indeed, all the elements are put in order from smallest to biggest. Okay, so there are a few other little things we should do to see if we can make this a little bit more efficient. And I'm going to show you a little. So basically, what would happen if I didn't switch? Like, I already had the smallest. And so it would mark the smallest as where I already am. But then down here, it would still flip the smallest with itself. So it would, like, if the smallest was in slot 5, this algorithm right here would switch slot 5 with slot 5. So one of the things we can do is we can put in a Boolean variable, because that would not be efficient if we didn't. If it's already in order, we don't need to flip two things around. So I'm going to create a little variable there called switched. And then right here at the beginning of each looping, I'm going to start switched off at false, because at this point in time we haven't switched anything yet. So that would make sense. I have to spell it correctly. So there you go. And then if I find something that needs to be switched, then I can say switched equals true. Okay, so that means I found one that I need to switch. So then I only want to switch if I need to. So if switched is true, then I'm going to flip my two elements around. Oh, switched. That's all I have to say because it's true false in itself. And then I'm going to indent these right here. And hopefully that's all I need to do. Check my work over here. Save that and run it again. And indeed it's still in order. Now to see how this affects the amount of things we have to do, I am actually going to take my step 3, which is printing out the array, and I'm going to take it and put it inside my J loop. I think this is where I want it right here. So now this is inside my J loop. So hopefully this will give us kind of a window of what happens every time we go around. So now we can see, now if you look down here, you can see the -2 is put in position, and the 0 and the 6 flip. See, here's the 6 and here's a 0, and that flips. And then the 1 flips with the 7 on the third go round, and so forth and so on. And so the 4 gets into place, and then the 5 does, and the 6 and the 7. So my question is this. If the array is already in order, so let's just put an array in order. Let's just make a simple array. If this is already in order, it shouldn't switch anything, and it shouldn't have to go through all these steps because it's already in order. So let me just go ahead and run this. Now you're going to notice something here. Even though there's no switches that have been made, it still cycled through 4 times. And this is the inefficiency of the selection sort right here. The selection sort is good for an average size array that is not already in order. Now if I go over here to my my bubble sort that we used, and I did the same thing. So let's say the bubble sort is nice in that if it's already in order, it doesn't flip through 4 times. It didn't go through 4 times, whereas the selection sort does go through. So that's one of the differences between the bubble sort and the selection sort. I hope this has been helpful for you, and type these in and try them yourself, and we'll get back to you when you're done. Thanks, and we'll see you later.